Welcome back to Made Up of Wires, where we are decompiling Castlevania Symphony of the Night. As always, you can go to soten.z.dev if you want to learn more about the project. You'll find a link to GitHub near the top, where you can find all the code that we've decompiled on the stream and all the code that other people have decompiled as well. There definitely are people who are getting a lot more in than I am lately. You can find a link to Discord as well, where we're chatting about decompilation tooling, mods to Symphony of the Night, and lots of other things. And of course, you can find the progress for all of the overlays that we've been working on as a whole, not just on the stream. I'm just a contributor to the project. I am not the project maintainer or anything like that. I just like decompiling and I like Symphony of the Night. We've been working on Doppleganger 10 and Doppleganger 40. We finished off a function except for some registers yesterday. I haven't had a chance to work on that anymore. So I haven't done anything with it, but I did get the stuff that we have been working on other than that function checked in. And so we have a little more progress on RBO5 and BO4, Doppleganger 10 and Doppleganger 40. I'm going to do something a little different and put up some slides for the talk that I have next Saturday at Game on Expo. Feedback's appreciated, obviously. And we'll see how it goes. So this is also, I thought, possibly something I could compress into a YouTube short, which the algorithm likes. So what is decompilation and what are we doing here, besides my head being on top of the slide? So what is decompilation? When a game is created, programmers from the PlayStation generation forward are using a high-level language like C. Symphony of the Night specifically is written in C. And they take that code and use a compiler. And that compiler, we write code in C because it's relatively human readable. People can work on it together and understand the structure and syntax. A compiler converts that to assembly language, and assembly language is how games used to be written. And it's not something that computers can read, and much lower level than what C can do. But it kind of allows separation of concern, so a compiler can produce assembly language, and we'll see what happens to that assembly language next. But it's a representation of what the machine, computer, game system will do. For Symphony of the Night, we're looking at GCC for the PlayStation and MetroWorks for the PSP. An assembler takes that assembly language and converts it into machine code, and this is something that the CPU of the game system can run. And that machine code then is written to the disk and is what is loaded and played when we play the game. And so for decompiling, we want to go in the opposite direction. This process is lossy, however. We're taking C code, removing all the variable names, removing anything that the machine doesn't need, and converting it just into bits that will be read there. So for decompiling, we start with the game. We don't have anything other than the files that are on the game and maybe some ideas of how things might work. We can get the machine code from the disk because that's what the system needs to play. That machine code we can convert reasonably well to assembly, pretty much perfectly. There's a few things in assembly that we might want that would make it nicer. So are there addresses that are special that we normally would have given a name to, things like that? Is there data that goes along with the code that we're decompiling? But this is mostly a mechanical translation process. And then we use the crowd and people who are interested in volunteering to convert that assembly back to C. And it's a lot of C. We use a bunch of tools. Splat is how we take those files from the disk and split them into different segments that will be represented as C files. SPIM takes the machine code that's extracted by Splat and converts it to assembly. M2C gives us a first pass at converting that assembly language to C. Decomp.me is a collaborative editor that integrates M2C as well as some tools for diffing C code that we write with the assembly that we're targeting. And then decomp permuter is for cases where we can't necessarily figure out what C would produce the assembly that we're targeting. And it goes through and makes several hundred small changes that would be time consuming for a developer to do. We also use a ton of open source software. Basically, a decomp project is run a lot like any other software engineering project. We use GitHub, Git, Make, Clang, GCC, Docker, DOSBox, several different languages, Rust, Go, Python. I use Vim as a text editor primarily. And so this looks like the tooling that you'd use on any modern software project. The next thing we need to do is disassemble carefully the files that are on the disk, and we're going to do that with Splat. We take a file from the disk, in this case send.bin. This is the center area of the castle. And that file is going to be broken up into different segments. A data segment, RO data. Data is things about the level, maybe attributes for different entities, which entities exist in general, what lookup tables to use for colors, other things like that. RO data is things generated by the compiler that are usually not things that people write directly. Sometimes it is. It could be text that is written into the code itself, but it's also data for jumping to various locations called jump tables that might be there as well. Text, it's called the text segment, but it's actually where the code lives. And then a BSS segment, which is more data, but it's uninitialized, so it starts out as all zeros. So knowing the order of those segments, we create a Splat configuration which contains offsets into this file that map to one of these four. And each of these segments is going to be associated with either an asset, so some data sprites or scripts or other things like that, or a C file. And we're going to focus primarily on the C files. We give this file to Splat along with our original relay, and Splat will generate a bunch of C files that correspond with all these segments, as well as a script to link all these back once we compile them. If we look at one of these C files, what Splat generates is something that's dissimilar from what you might expect, but it doesn't know any of the C code yet, and that's our job to provide the C code. What it does provide is basically a skeleton for us, and every function that's identified has a placeholder with an include ASM macro, and that's going to include that's going to put the assembly for that function into the C file, and the compiler will take that and produce the machine code that we need. And this is what the assembly looks like for us. All this so far, we have to manually segment the file on disk, but this C file as well as the assembly that's extracted, that's all an automated process. We need to take this assembly file. I like to use a tool called Decomp.me. We paste that assembly into the target assembly. We have a bunch of presets, in this case for Symphony of the Night. A context which acts as a header file, which will give M2C some hints as to types, what specific data means, what symbols have a particular shape or value, and then create a new document. On the left is some C code that M2C created. This is not necessarily what the final C code will look like. There's a lot of go-tos and other things like that that we wouldn't necessarily expect to be in our final C. But it's a skeleton that allows us to have some structure for how we're going to decompile. In the middle is a target column. That's the assembly that we uploaded, and that's what we want our C code to reproduce. The Symphony of the Night decompilation project is a matching decomp project, which means we want to write C code that will compile back to exactly the machine language that was found on the disk originally. We want to be able to reproduce those binaries exactly. And so our C code in decomp.me compiles to what's on the far right column labeled current. And then at the top, there's a counter that shows us how many differences are between the two and how close we are. In this case, this initial pass is 40.91%. And then it's our job as decompilers to go massage this C code to something that will match the target exactly. So in a nutshell, that is the decompilation process. If you want to know more, go check out the talk at Game On Expo on Friday. But for now, we are going to actually do some decompilation. So, like I said, we've been working on Doppleganger 10 and 40. And that's what we're going to continue on today. I'm going to go look at the duplicates report. We're getting to a situation where some of the remaining duplicates may be more complicated than I want to do on stream, mostly because they take a while, and I like to try to get something end-to-end when I can on stream. It's nice to have functions that take a couple streams to show that there is complexity here. It's not all upload it and it's done, but it's also kind of cumbersome to do one of these decomps over several days. So I'm going to go to the duplicates report. This is a report that we have which will cluster functions that are similar together, and we can identify things such as this, where it looks like somebody has not mapped this symbol correctly. But we have all of these functions that are the same, and they exist in basically every stage overlay. There's a lot of functions like this. We're going to focus on the things that are specifically in RBO4 and RBO5, which is Doppleganger 40 and Doppleganger 10. Bosses act like stages, so we'll have all the same functions there. And we have a bunch still here that have not been deduplicated yet. So let's go through these. Some of them I think I've started. I know other people are working on. We don't want to take something too large, but we also don't want to take something too small. And so I'm going to use find to see what is left. Looking at the ASM directory for the US version of the game, this follows the directory layout that's on the US PlayStation release. It's the same layout on any of the PlayStation releases. So boss BO4, this is Doppleganger 10. We want non-matching functions. I don't really care where these are. This will split out into the different files that that still have non-matching functions. We still have some in this. I want to expect these directories just still exist, even though there's nothing. So we want to look for files that end in .s. These are assembly files. I'm going to use the ls option to print out all the attributes about the file, including size. I really just want the size, which is going to be in column 7, and the name of the file, which is in column 11. Then I'm going to sort by the size, oops, not 4, and look for something maybe around 3 or 4K in size that also exists in this duplicates report. Hey, roaming. Hey, Mozzella. Good to have you back. And hasn't been started by me or somebody else. I'm going to start with this BC0. Let's see if that is over there. This is going to take a little bit of trial and error. It is, and this is actually in DRA as well. So this is matching in DRA, Doppleganger 10 and Doppleganger 40. I probably have started this if it hits all those boxes, and there probably is something funny with this that that I couldn't figure out. So let me go to decomp.me, and I'm going to save this one off. This one this one is merged in already. I'm going to look for that. It hasn't been started. I don't know anything about this function, so we can go back and look at that. Mozzella, I know I was talking about that clock tower script. I put a PR out that makes it more scripty, with kind of a little DSL around each of those. All right, so I'm going to be looking for that function. And I do want to look at the DRA version of this function just to get an idea of what this is. The DRA one is... so this is... So there's a version in Richter, but the version in Richter, excuse me, is not similar enough to show up in the dupes report. But this is actually a very simple one. Should go pretty quick. This matches 100% for RBO 5 and BO4. So I'm expecting to be pretty straightforward. I do want to look to see what the most complicated thing that we have here is the signature. We can see what M2C would figure out if it would figure out all these types. My guess is that the primitive, it's probably toss of a karma coin regarding whether it would get that or not. So let's see. Let's go over and create a new scratch. I'm gonna do it without the signature, and then if it doesn't get it, we'll put the signature in. I started one scratch one time with PlayStation 2, and Decomp.me won't let me live it down. So obviously M2C, what it produces is going to be a little messier. It did not figure out that this was a primitive, so I'm going to go back and grab that function signature. It also doesn't know what the one global type is, and so we'll have to figure that out as well. Actually, we don't need to figure it out. DRA will tell us what it is. I'm surprised that I haven't found this one yet. There's a lot of this code. Basically, all of the Alucard code is all of the Alucard like ability code is in these Doppelganger overlays as well. Yeah, I saw your comment in thanks, roaming. Yesterday we looked at object diff, and it actually I do have the PS1 version here, so object diff should be right. I'm sure that there's a configuration setting. I've not looked at it anymore, so I don't know anything. So this is going to be an unsigned 8 array. We can get some of that context from here. It is a little bit difficult though because of how this is structured. Usually when you have some pointer to a global and then a multiplication and an addition next to it. Usually that means the stride of this, it's an array, and then the stride is of size 8 bytes. And so there's no 8-byte type on the PlayStation native type, so that would be a structure or another array, so it would be an array of arrays. In this case, that's not true. Somebody else has figured out this for us already, and so I'm going to use that information to my advantage. And I'm going to throw this in the context as well, and then run a new decomp. We don't actually need this, but I'm going to do it anyway, just to get a clean file. We can't run object diff yet, so we get a bunch of things that are unknown. It still can't figure out certain things, and so I'm going to cheat and use the DRA implementation. And I think all that's going to change really is what global we're pointing to. So this one's super easy. If you are interested in decompilation, though, it is a good habit to not do work that you don't need to do. That's true in any job. So we're at 98.31. That's not perfect, but not bad. We'll update the comment there. The first thing that I see up here is that we're loading the value 6, we're loading the value 10, and we should be loading the value 6. I think that, no, it's not related to this. Let's see where that A0, oh no, it's offset. Sorry, offset 6. I believe that's because I have the PSP version of the primitive struct. I'm going to hope that that's the case. That is the case. The PSP has an extra 4 bytes at the beginning, and that changes their offset, and once that's gone, we have a perfect match. Let's look at object diff and see what's there. I have, in my context, I have this G interactable. It must not be set to extern. We'll fix that, fix up the context, and then everything else is matching. It's not really interesting, but this one is done, and this was our BO4 version. The only difference between this and RBO5 is going to be what global we're pointing to. If we name those the same thing, then we would have no code differences, and eventually this will probably be pulled out into files to do that. So let's go to source boss BO4, and this was in unknown 467, and this function was BC0. And let's grab this extern. Yeah, there are cases actually roaming. That's a good point. And I don't know if you were in that conversation maybe a month ago or so. There was a conversation on Discord where MetroWorks needed 2 functions compiled in the same compilation unit, and it used information. So MetroWorks typically for the overlays is the optimizer is disabled, and it still was using its knowledge of another static function in that file to avoid using some registers in a function that was going to call it. And the only way that compilation would work is if you had both of those functions being compiled together. Yeah, that was one I hadn't seen before. I wasn't the one who discovered it, just kind of lurking around that conversation. So let's build that, and that builds fine. So I'm going to do what I normally do with these really simple ones, and that's not go back to decomp.me for this. I do need to find the name of the and what file it's in. I'm just looking at the duplicates report to get all this information. So it's going to be in this file, unknown4648C. And the RB05 version is named this other address. That's just because they're at different offsets. And so I can take all of this from RB04 and use that. However, this global is going to be wrong. And so I need to get the symbol name of that global. So I'll grab the assembly file. I'll just grab the whole path from the groups report. And it loads, and you can't even tell that anything changed, but there is indeed something different. And this is the symbol that we need. And so we'll replace that symbol here and make again, and that should work. Oh, what? I'm gonna replace it here and replace it here. And since I have it in the comment, replace it here as well. Copy the function name as well. We need the correct function. This has been mapped. I think this was auto-mapped by makeconfig to have the same name. I'm going to do that for BO4 as well. Let's see if there's anything in here that's using this. There are a few things that are. So I'm going to rename this. It's possible that this is static. We can figure that out. If it is static, then we don't have to update symbols. We can just update the C file, and we can figure that out by searching through. And there is one additional. Oh, that's in the same file. So this is static. So we can mark these as static. Static limits visibility to this file. And we don't have to add a symbol then to the symbols table. So let's make again, and that all works great. So we got another one done. Let's keep going. Hey RJKS, good to have you. All right, let's move on to the next one. Do we have? We actually have, I think, a few more here. The next one is this entity player outline. Let's look at that in DRA and see if how complex that is. Is it not in that file? Some of these outline functions are really crazy and relatively complex. This one actually, so far, doesn't look too bad. But because this function is responsible for basically all the outline variations. It can get pretty tricky pretty quick, but this one I don't think is actually too bad. So let's do this. And it's a nice named function. And if we come up with... the jump table is awful looking, and that's fine, because I don't think we're going to run into too many issues. We will find out. The biggest issue here that I see in the dupes report is that these are 92% the same as the DRA version. I'm hoping that it's just some cases that don't apply to Doppleganger that are missing, and not something that's significantly different. So our new Scratch entity player outline, fortunately, is an entity, so we know the signature for that. Thank you for the sub, RJ. So we're going to see a lot of Doppleganger entity field access. Those are going to show up as player in the DRA version. But the structure looks very similar. So we're going to have to figure out this signature, but that should be there as well in DRA. So these are actually really nice. This is kind of a chill decomp. So I'm going to grab that. I'm going to paste. Maybe I should paste more than just the name. And so we have a few globals that we need to take care of. These globals are different from... These are the globals from DRA. We need similar ones that are going to be in this case, Doppelganger. I grabbed the RBO5 version. Usually I do the BO4 first, but so let's grab those. So we have this first one here. We'll see what that type is. Usually, so this is an array of signed 16s. Signed 16 pointers. So it's an array of pointers. And then we need this other as well. I'm doing the same thing. Back in the terminal. And this other is very similar, but we have we know the shape a little better. So now we can see where the differences are. The first thing that we need to do is replace any player references to Doppelganger, and that should be get us a little closer. We'll see. So I'm going to do a case-specific find and replace. That didn't change anything at all. The other thing that we'll see is G player, I'm guessing. Any G player needs to be replaced with GDOP, which is the player state for Doppelganger. And I think that's a good start. So what we're going to do now is look at where the differences are. and see if there's there's things that we can identify that are different. So we have a relatively large condition at the top, which is basically checking to see whether or not the player is, whether or not the player is dead or incapacitated in some way. It's a little more complicated than I'd prefer, but that's okay. Let's see which ones we need and which ones we don't. So animation set we do need. And it looks like the status may not be read right away, so I'm going to get rid of the status check. The palette is the palette constant. Here is not being checked. So there's still something looks like animation set is possibly being checked specifically against 0 as opposed to a not. No, that didn't change code gen at all. Let's see what M2C tells us. So the value that's being compared is quite a bit different, and these are backwards. The step is also not being checked. So you can get rid of the step. So we need to see what this 3,4C is. This should be part of the Doppleganger entity, and I don't have that mapped, but should. Actually, no. So I got rid of all those statuses. That's what this was. I'm going to put those back. So currently, we need to figure out what, which one of these is the 80 in this 8.7. I'm gonna guess dead. Not dead. Well, can't be axe armor. Oh, I'm looking at the completely wrong one. We're looking at this constant here. Basically, we need to reproduce this constant, and it was dead. So as long as there's going to be a different set of functions for Doppelganger if Doppelganger is dead. And so we have that figured out. This animation current frame check I don't think is happening. So I think this gives us what we need. This destroy entity is going to be way at the bottom. So now we have the branch equals 0. So all of this looks correct. It looks like it was just a kind of a minimized version of what was up there. There is an additional code at the top here that we're not doing, and so we need to grab that. I'm going to position X mapped. That's a little strange. Oh no, I do have position X map. So there's one more Doppelganger field that we're not grabbing. So let's look at what this 7632 offset is going to be. I'm going to go to, this is RB05, symbols, US boss RB05, and I want to see what the starting address for Doppelganger is. Oh no, it's just in US. Starting address is this. I'm going to take the offset here. I do this off screen, but you can do it yourself with a hex calculator. So the symbol is given the address that it is going to exist in memory. So I'm taking that minus where the Doppelganger entity starts, which is here. And that gives me an offset of hex 54. And then I can go to the entity structure and see what is at offset 54, and that's anim set. So there's an additional read of anim set that's missing, and I think I got rid of that probably by accident as well. Let's find where that was. We have a read of anim current frame. That's what's missing. So I got rid of this too eagerly. That should be there as well. So let's add that back. And again, it's going to be Doppelganger, not the player. And it looks like these might be in a different order. And that's just what it needs. So I think it's interesting, and you try to get in the head of the people at Konami who were developing this originally, and like, why would they make some, one decision over another? And would you make that same decision if you were writing this, for your job? And a lot of the Doppelganger code is identical to the Alucard code, and a lot of the Alucard code is identical to Richter code. And I think this is more common, especially if you're trying to move fast. But these functions were just copied and tweaked to fit the situation. And this is a relatively large function. So nowadays we might take this and, maybe this is a class in some modern programming language or OO programming language, and we're just tweaking things based on attributes of that class or overriding certain functions. But that's not what they did. They copied this function and then just tweaked things. In this case, they changed the order, which is crazy. That may suggest that there was, an early divergence of these functions, and then somebody said, "Hey, we need to check this current frame to make sure that it's not this special value. This looks like a special value to me. It's Sign 16 max. And we do have a macro for that. Right? No, I don't have it in my context. It does exist in types, though. In 16 max. Let's see if that's built in. It's not. That's what we'll add it. So it could be checking for overflow, or that often the max and mins are used as special values, because there's never going to be 65,000 frames for the Doppelganger animation. All right, so along the way here, I fixed this global to point to the right version. And then down here on 51 is our next difference. So it looks like we're just assigning a value here as opposed to doing an OR. And the value that we're assigning is going to be, or maybe we're not even doing this. So we're not updating the draw flags. Doppelganger's draw flags, though, are being updated. So this does need to change. And then that matches. It doesn't look like this is still not ORed, so nope, it is ORed. We're reading Doppelganger's draw flags and we're assigning them back, not to Doppelganger, but to self. Okay, so that's fixed. We'll see this in DRA, which is the game engine, versus one of the overlays. The game engine can access these functions directly. The overlays need a pointer to them, and that pointer comes from GAPI. So it looks like prim index is what did I do? I'm parentheses in the wrong place. Let's think about this a little more. So the pointer that pointer that's being loaded is it looks like overshoots what we need, and then we're subtracting a value to get back to it. That's a little odd. Actually, I see some immediates that we should fix first. Where are those? Not flags. Flags, I'm gonna turn this back into just the constant value, and I'll let Soat and Lint come back and fix that for me. I'm not sure why. Why that's happening. Our texture page is different. Instead of 18, it's going to be hex 10, which is 16, 18, 24. So what is going on? So when we often GCC will look at how when a pointer is being loaded, what fields are being accessed, and it might say, if I choose priority, I only need like 8 or 16-bit operations to get to these other fields as well. And so I know you want to load you know, the address of this primitive, but if I load a couple bytes in front of it or a couple bytes after it, that makes other operations easier or cheaper. That may be what's happening here. That's why I think the sub may be there. I'm not quite sure what's going on there. We can look at the M2C version and see what might be going on. Oh, our flag is quite a bit different than I expected. Go fix that, then that should fix one of those instructions. So we have our primitive index times 34. The primitive buffer is full of primitives, and each primitive is of size 34, so we expect a multiplication there, M2C. Unfortunately, can't figure that out at the moment. That primitive buffer is of, the stride is hex 34 bytes long, and so this is unnecessary when doing the pointer arithmetic. But there's nothing funny there. Seems like it doesn't even know that primbuff is a primitive. Is that true? You must have that in there, yeah. I don't know why M2C is not recognizing that and not assigning varus 0 the right thing. There is a reference to the animation set that doesn't exist. This is a little hard to read because we don't have field names here. But looking at what these are, so this is the T-page line. This appears to be the color lookup table line. Unknown 26. Let's look at. Oh, sorry, not showing you the right thing. I'm looking at these 3 lines in the M2C decomp versus what we have here. I'm going to go back over and look at primitive and see what offset 26 is. Its priority. And this is one of those cases where we're just, this is a SPIM-ism. The closest address was this animation set. We want 30 bytes before it. So I think that this is going to be the same as Z priority. There is something different in this area that oh no, it all worked out. When I fix this, it looks like it. Oh no, still wrong. Excuse me. Let's look at this loop over in the decomp and see if it's kind of an odd loop. We're only doing this once. I'm not sure what is missing. Let's look at V0 and how it's being used. V0 is being added to primbuff. So it's something with this primitive index and how it is, how it's being used. I would imagine this is how it's calculating the offset. So basically this is the, we don't see it, but this is the multiply by hex 34, just an extremely efficient version of that. I'm not quite sure what's going on there. So I'm going to keep going. Let me double check that I might still have the wrong primitive. I didn't think about that before, and I do. Maybe that's going to clear all this up. Let's hope. Yes, got it. So it was using a 38-byte primitive versus the 34-bit primitive for the PlayStation. When you modify the context in decomp.me, if you do it when you're creating a new scratch, that's going to be your context going forward. All of your new scratches will have that same context. And so I added that when I was creating a PSP context. That is what screwed me over there. The draw mode, we have the wrong value. We need 6, but we have these others. I'm going to try getting rid of that. So it's not draw colors, it's draw colors and draw unknown 2. Might be O2. Why O2? I don't know. All right, continuing on, we want to find this on line 72. So the number of cases that we have, and hopefully this becomes easy to identify, but the number of cases that we have is 24, but there's only 23 that we need to target. So hopefully there's something obvious here that we can find. We can see what offsets into the jump table each of these are, and so we want all these to be the same. This actually may be a good use of object diff here. Let me get rid of my e-interactable. It kind of stinks that you can't save off your context. And I could create a new scratch just to save my default context. But I tend to not remember that I that I have to make these changes each time. So we want RO data, and it's actually telling me RO data is so different. How different is it? It's so different that it's 0%. And why are you not giving me my jump tables? Yeah, this is exactly when I would want to use objective. Just tell me exactly this. Interestingly, both of them are 120 bytes, but it's 120 of the wrong bytes. I also think that a little interesting that 3 jump tables came along, because I don't remember 3 jump tables Oh, there were 3 jump tables. Huh. Okay, so we have extra cases here. The way this is a little tricky to debug, and which is why I wanted to use Objective. But basically, we can look at all these. So every offset in the jump table is going to be represented by values here. And so both have 0, both have x22, 24, 28, 2c, 30, 34, 44, 48, 50. And so our last one, 5c, is missing from the original. So that is not something that Doppleganger can do, and that looks like Sword Brothers. So let's take that one out and see if that matches, and now it does. And does this number match? It does as well. So that ended up being a very simple way to fix that. Let's see what happens if we create an RO variable. We'll say obviously this does not exist in the original. I'm not getting any RO data like listing here. Now our RO data is different again. I know that jump table is correct. Well, I don't know that it's correct. It's the right size at least. I don't know. I don't know yet what I don't know. So, well, let's go back down here. And call from Bullhead City. Don't know where that is. This is our second jump table where we have basically the same thing. I'm going to assume Sword Brothers is something that Doppleganger can't do, and that fixes that as well. Yeah, we can try global const. No, it's fine. It's fine. Let's try. I'll still do a char star because then I can make it relatively big. And that shows up in data, which is interesting. Why would it show up in data? If I make it static. So is it just the... Let me add more data here. So the string itself is going to RO data, but the pointer to that string is in data. Oh, compilers. Fun. My guess is that there's going to be one more. I'm not worried about these immediate values. I think these are all going to be correct. I'm making that assumption. It's a big assumption to make. I think there's going to be one more Sword Brothers entry to fix, and then way at the bottom, this function call here is for GAPI. We have a type difference that needs to be dealt with, and so let's okay, so it's going to v0, and is v0 being moved into an argument register? Nope. Let's see. So this is an offset into S1. S1 is our self variable. So let's see what offset 14 is in an entity. Facing left. So facing left is getting loaded as a byte here. And that's because the function signature is likely specifying it as a byte. Let's look at the function signature. We can't really get rid of this function signature. We need to know what it is, but it's being treated as a like the entire thing. So I'm gonna try to force this. I think we have a macro for load. It doesn't matter because of how this function signature is being loaded. Let me cheat and change this. And then is it correct? It is correct. This is unfortunate. Not the end of the world. I might have to cast this function. I should look to see who else is calling this function and what the signature is. Oh, sorry. I was looking for differences. I see our target is loading a 16-bit unsigned. We're loading a single byte unsigned. That's because the argument here is defined as a single byte argument. So the top 8 bits are just going to be shaved off anyway. I want to see what the signature is for this 578. Possibly it's just a bad signature, but I'm not sure. So let's look in DRA for that. So the signature here is unsigned 8 as well. And let's see if anybody else is calling this outside of DRA. Nothing in stage. Richter, nothing in Richter. Weapon, nothing in weapon. Nothing yet in boss. So we're the only caller. So if nobody else is calling this, I think it should be safe to change the signature. Because this seems like the only place that it's being used. Sometimes it's a little odd that some of these are duplicated versus the DRA version being called. Not sure why. So we have stage boss, servant, weapon. So then we need to figure out, is the DRA signature wrong? And what happens if we change this to a signed 16? Or even an unsigned 16? Actually, what if it's an unsigned 8? No, it originally wasn't unsigned. What if it's a signed 8? Will that make a difference? not in the way that matters. It's assigned 16, also broken. So it needs to be unsigned 16. So I'm going to change it to an unsigned 16. Then we're going to change it everywhere else in DRA and see if it still compiles and matches. These I'm always a little nervous about. Because somebody already had a good reason to make this a unsigned 8. And I'm not familiar with this code, so I don't know. So that does make DRA fail. And what if the signature is just wrong? So again, nothing uses this. I only need the signature to be correct where the function is defined. So I'm going to take a gamble and change the GAPI signature. I'll make a note here. And then we'll change that in the context as well. And this, it may work, it may not. Like I said, this is the only thing that seems to be calling this function. So hopefully that's correct. And so what else are we missing? Anything? A function at the bottom. Usually on the PlayStation this should be an even number. And so my guess is I'm missing something else at the top. Still missing. I need to be loading 87 or 7. I'm loading 87. So let's see what player status I have wrong. So I want to look at player status. We're looking for 80, so stone. Apparently you can't stone Doppleganger. We have another value. Actually, this one I'm not worried about. Let's look at line 42 just in case. Oh, sprite sheet pointer. We do need to fix this. My guess is that this is a macro that's used for porting compatibility. And it's the same value. This isn't. So we need the sprite sheet, not not the global sprite sheet, but the one for the overlay. So let's look at that though. That's in game.h. And I'm not sure that we have that symbol. So if we want to use that, we need oh, we can't use this. So it doesn't matter. This is it will be the sprite sheet type, which is just unsigned 8 pointer array. And we'll just use the global. I do want to see where this is being used, because that will need to be changed as well. And so the remaining, I'm hoping, are just going to be immediate differences that point to different entities. Those are things that I could map in the symbol table, but I'm not, especially these that are not currently mapped. Everything else looks good, so I'm going to try to take this over and see if this works. So we're in RBO 5, and this was Entity Player Outline. And it did, first time, wow. So now we need to do the same thing for Doppleganger 10. The only differences that we're going to have, I believe, are going to be the globals, and so we'll try to do that. This one's going to be a little trickier because it's bigger, but we'll try to figure it out. These files are laid out very, very similarly. We have another function up here. This one was mapped to one of the DRA functions, whereas this one was, oh, sorry. Show you again, it did build. So I'm going to go and open the DRA one. Or sorry, not DRA, the RBO BO4 Doppleganger. And so now we need to look for some of these globals. This is going to be a little trickier than maybe I want to do right now. This is going to point to various doppelganger things. So let's get a draft. I'm going to split this with the RBO5 version. And then I can see what line these globals are on. Too many tabs open. So first I'm going to look for this B50. It's only 141. And so that's going to be this guy. Okay. Then this C00. On line 182. And then the last one is 443. On line 182. Oops. Oops, oops, oops. I pasted instead of operating system buffer pasted instead of vim buffer pasted. Let's see if this works. No reference to this function. So we need to find that function as well. And I didn't provide a signature to that function. And that's okay. The default signature is working. Sorry, went the wrong direction. Where did I go? I'm lost. Too many tabs. And that one works as well. So we got another one in the can. So there's a bunch still here. I did look at Entity Mist. Entity Mist is relatively complex. There is a lot of external data that it references, and so I think most of it is just mapping that, but kind of boring. Most of these were a little boring today. I'm not going to do any more today, but I will look at this. Some of these last ones that were, they did get a match for DRA in RB05. Between when I imported Doppleganger 10 from when I imported Doppleganger 40, something must have changed to improve matching, and I got the symbols on RB05 and didn't get them on BO4. So who knows? Not me, that's for sure. So I'm going to be at Game On Expo. Look at that. They still don't have a schedule, but I'm going to be there on Saturday, April 5th at 7 p.m. talking about decompiling Castlevania Symphony of the Night. It's probably going to be a little higher level than what we do on the stream, but I am going to try to do some decompilation live in front of a live audience. Not that you in chat aren't live. If you're watching on YouTube, you can see this live 4 days a week for free. You don't have to pay admission. I give it away. If you're in the Phoenix metro area and plan on going to Game On Expo on Saturday, that's a week from this Saturday, come by and say hi. I think I'll get there in sometime in the afternoon. I have some things in the morning, but I'll be around the expo floor, and there's a few other panels that I think we'll try to pop into. So if you see me, say hi. Make sure you introduce yourself. We've been working on Doppelganger 10 and 40, and we'll keep doing that as things go. I'm probably not going to do... the stream over the next 4 days will be relatively low-key. I'll probably put some of the stuff from the talk in sporadically like I did at the beginning of this stream, just to talk through the things that I am going to say next Saturday. Go to soten.z.dev to learn more, and I will see you next week. What could possibly go? Is it going to be recorded? I am not recording it. I don't think they have any recording equipment in the room. So no, I don't think it is. But I'll, if it goes good, I'll just do a stream that is the same thing. If it goes poorly, be thankful that it's not recorded. That's it. I'll see you guys on Monday.